A circle. What is a circle? A circle is the set of points in a plane that are at equal distance from one given point. This point is called the center. The radius is the distance from the center to the circle. A chord is a line segment with endpoints on the circle. A diameter is a chord that passes through the center of the circle. It is the longest chord of the circle. A secant is a line intersects a circle in 2 points. A tangent is a line that intersects the circle in exactly 1 point. A point of tangency is where a tangent line touches the circle. Congruent circles. Congruent circles are those having the same radius but different center. Concentric circles. Concentric circles are 2 circles that have the same center but different radius. Intersecting circles. Coplanar circles having 2 points in common are called intersecting circles. Coplanar circles intersecting in 1 point are called touching circles. 1. Externally touching in point A. 2. Internally touching in point B. Common tangent. A common tangent is a line that is tangent to each of 2 coplanar circles. A common external tangent does not intersect the segment that joins the centers of the circles. A common internal tangent intersects the segment that joins the centers of the circles. Tangent theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. Given, line L is the tangent to the circle with center O at the point of contact A. To prove line L is perpendicular to radius OA. Proof. Assume that line L is not perpendicular to segment OA. Suppose segment OB is drawn perpendicular to line L. B is not same as A. Now take a point C on line L such that A'(B')C and BA is equal to BC. In triangle OBC and triangle OBA, segment BC is congruent to segment BA. By construction, angle OBC is congruent to angle OBA, since each is a right angle. Segment OB is congruent to segment OB. Therefore, triangle OBC is congruent to triangle OBA by side angle side test. Therefore, OC is equal to OA. But segment OA is a radius. Therefore, segment OC must also be radius. Therefore, C lies on the circle. That means line L intersects the circle in 2 distinct points A and C. But line L is a tangent. Given. Therefore, it intersects the circle in only 1 point. Our assumption that line L is not perpendicular to radius OA is wrong. Therefore, line L is perpendicular to radius OA. Converse of tangent theorem. A line perpendicular to radius at its point on the circle is a tangent to the circle. Given, M is the center of a circle, segment MN is a radius, line L is perpendicular to segment MN at N. To prove, line L is a tangent to the circle. Proof. Take any point P other than N on the line L. Draw segment MP. Now, in triangle MNP, angle N is a right angle. Therefore, segment MP is the hypotenuse. Therefore, segment MP is greater than segment MN. As segment MN is radius, point P can't be on the circle. Therefore, no other point except point N of line L is on the circle. Therefore, line L intersects the circle in only one point N. Therefore, line L is a tangent to the circle. Tangent segment theorem. Tangent segments drawn from an external point to a circle are congruent. Given a circle with center A, an external point D of the circle, and the two tangents through the point D are touching the circle. To prove, segment DP is congruent to segment DQ. Construction: draw segment AP, segment AQ and segment AD. Proof: in triangle PAD and triangle QAD, segment PA is congruent to segment QA, since radii of the same circle. Segment AD is congruent to segment AD by common sides. Angle APD is equal to angle AQD is equal to 90 degree. Using tangent theorem, therefore triangle PAD is congruent to triangle QAD by hypotenuse side test. Therefore, segment DP is congruent to segment DQ. Example: in the adjoining figure, O is the center of the circle. From point R, segment RM and segment RN are tangent segments touching the circle at M and N. If OR is equal to 10 cm and radius of the circle is equal to 5 cm, then 1. What is the length of each tangent segment? 2. What is the measure of angle MRO? 3. What is the measure of angle MRN? Construction: draw segment OM, segment ON. Solution: in triangle OMR, MR is a tangent segment and OM is the radius. OM is equal to 5 cm, OR is equal to 10 cm. Angle OMR is equal to 90 degree. By tangent radius theorem. In right angle triangle OMR, OR square is equal to OM square plus MR square. By Pythagoras theorem. 10 square is equal to 5 square plus MR square. 100 is equal to 25 plus MR square. Therefore, MR square is equal to 100 minus 25. Therefore, MR square is equal to 75. Therefore, MR is equal to square root of 25 into 3 is equal to 5 square root of 3 centimeter. Using tangent segment theorem. Length of each tangent segment is equal to 5 square root of 3 centimeter. 2. In triangle OMR, angle OMR is equal to 90 degree. By tangent radius theorem, OR is the hypotenuse. Therefore, OM is equal to 5 centimeter, OR is equal to 10 centimeter. Here, OM is equal to half of OR. OM is equal to half into hypotenuse. Therefore, OM is side opposite to 30 degree. By converse of 30 degree, 60 degree, 90 degree triangle theorem, therefore angle MRO is equal to 30 degree. 3. Triangle OMR is congruent to triangle ONR by SSS test or hypotenuse side or SAS test. Therefore, angle MRO is equal to angle NRO is equal to 30 degree. CACT. Angle MRN is equal to angle MRO plus angle NRO by angle addition property. Angle MRN is equal to 30 degree plus 30 degree. Therefore, angle MRN is equal to 60 degree. Try some more problems for practice. Touching circles. When two circles touch each other externally or internally, then their centers and point of contact are collinear. When circles touch each externally, then points A, B, C are collinear. Therefore, AB plus BC is equal to AC. If AB is equal to R1, BC is equal to R2, AC is equal to R1 plus R2. Therefore, distance between their centers is equal to R1 plus R2. If circles touch each other internally, then their centers and point of contact are collinear. Therefore, OBA are collinear. Therefore, OB is equal to OA minus BA. If OA is equal to R1, BA is equal to R2. Therefore, OB is equal to R1 minus R2. Therefore, distance between their centers is equal to R1 minus R2 since R1 is greater than R2. Note: in concentric circles, distance between their centers is 0. Theorem of touching circles. If two circles touch each other, their point of contact lies on the line joining their centers. Given C is the point of contact of the two circles with centers AB. To prove, point C lies on the line AB. Proof: let line L be the common tangent passing through C of the two touching circles. Line L is perpendicular to segment AC. Line L is perpendicular to segment BC. Therefore, segment AC is perpendicular to line L and segment BC is perpendicular to line L. Through C, only one line perpendicular to line L can be drawn. Therefore, points C, A and B are collinear. Example: if radii of two circles are 4 cm and 2.8 cm, draw figure of these circles touching each other, 1 externally, 2 internally. Solution: radii of two circles are 4 cm and 2.8 cm. 1. When circle touch each other externally, distance between their centers is equal to 4 plus 2.8 is equal to 6.8 cm. Two. When circles touch each other internally is equal to 4 minus 2.8 is equal to 1.2 cm. Try some more problems for practice. Arc of a circle. A secant divides a circle in two parts. An arc is a portion of the circumference of a circle. Central angle. When the vertex of an angle is at the center of a circle, in the figure, angle AOB is equal to theta is central angle. Like a secant, a central angle also divides a circle into two arcs. Major arc and minor arc. If the center of a circle is on one side of the secant, then the arc on the side of the center is called major arc, and the arc which is on the other side of the center is called minor arc. Measure of an arc. 1. Measure of a minor arc is equal to the measure of its corresponding central angle. 2. Measure of major arc is equal to 360 degree minus measure of the corresponding minor arc. 3. Measure of a semicircle arc is 180 degree. 4. Measure of a complete circle is equal to 360 degree. 5. Two circles or arc are congruent if their measures and radii are equal. 6. Measure of circle can be added or subtracted. 7. It can be multiplied or divided by non-zero number. 8. Measure of arc ACE is equal to measure of arc ABC plus measure of arc CDE. Note: 1. The chord corresponding to congruent arcs of a circle or congruent circles are congruent. 2. Corresponding arcs of congruent chords of a circle or congruent circles are congruent. Example. In the given figure, points G, D, E, F are concyclic points of a circle with center C. Angle ECF is equal to 70 degree. Measure of arc DGF is equal to 200 degree. Find measure of arc DE and measure of arc DEF. Solution. Angle ECF is equal to 70 degree given measure of arc EF is equal to angle ECF is equal to 70 degree. Measure of minor arc is equal to measure of its corresponding central angle. Angle DCF is equal to measure of arc DGF is equal to 200 degree. Measure of central angle is equal to measure of its corresponding arc. Angle DCE is equal to 360 degree minus angle ECF plus angle DCF, since measure of a circle is 360 degree, is equal to 360 degree minus 70 degree plus 200 degree is equal to 360 degree minus 270 degree is equal to 90 degree. Measure of arc DE is equal to angle DCE is equal to 90 degree, since measure of central angle is equal to its corresponding arc. Therefore, measure of arc DE is equal to 90 degree. Measure of arc DEF is equal to measure of arc DE plus measure of arc EF by arc addition property is equal to 90 degree plus 70 degree. Therefore, measure of arc DEF is equal to 160 degree. Try some more problems for practice. Inscribed angle. O is the center of a circle and vertex C of angle CAB lies on the circle. The arms of angle ACB intersect the circle at A and B. Such an angle is called an angle inscribed in the circle of in the arc. In the figure, angle ACB is inscribed in arc ACB. Arc AXB is intercepted by the angle. Intercepted arc. Given an arc of the circle and an angle, if each side of the angle contains an end point of the arc and all points of the arc except the end points are in the interior of the angle, then the arc is said to be intercepted by the angle. The arc is not intercepted arc as arm BC does not contain any of end point of the arc. An inscribed angle is half of the measure of the arc intercepted by it. Given, in a circle with center O, angle BAC is inscribed in arc BAC. Arc BDC is intercepted by the angle. To prove angle BAC is equal to half measure of arc BDC. Construction. Draw ray AO. It intersects the circle at E. Draw radius OC. Proof. In triangle AOC, side OA is congruent to side OC, radii of the same circle. Therefore, angle OAC is equal to angle OCA by theorem of isosceles triangle. Let angle OAC is equal to angle OCA is equal to x degree. Equation 1. Angle EOC is equal to angle OAC plus angle OCA. Exterior angle theorem of a triangle is equal to x degree plus x degree is equal to 2x degree. But angle EOC is a central angle. Therefore, measure of arc EC is equal to 2x degree. Equation 2. Definition of measure of an arc. Angle OAC is equal to angle EAC is equal to half of measure of arc EC. Equation 3 from equation 1 and 2. Similarly, drawing segment OB, we can prove angle EAB is equal to half measure of arc BE. Equation 4. Therefore, angle EAC plus angle EAB is equal to half measure of arc EC plus half measure of arc BE. From equations 3 and 4. Therefore, angle BAC is equal to half measure of arc EC plus measure of arc BE. Angle BAC is equal to half measure of arc BEC is equal to half measure of arc BDC. Equation 5. The center of the circle lies 1. On one of the arms of the angle, 2. In the interior of the angle, 3. In the exterior of the angle. Out of these, first two are proved in equation 3 and 5. We will prove now the third one. Angle BAC is equal to angle BAE minus angle CAE is equal to half of measure of arc BCE minus half measure of arc CE from equation 3 is equal to half measure of arc BCE minus measure of arc CE. Angle BAC is equal to half measure of arc BC. Equation 6. Corollaries of inscribed angle theorem. There are two corollaries. Corollary 1. An angle subtended by a semicircle at a point on the circle is a right angle. Given a circle with center O, angle BAC is inscribed in semicircle BAC and intercepts semicircle BXC. To prove, angle BAC is equal to 90 degree. Proof. Angle BAC is equal to half measure of arc AXC. Equation 1. Inscribed angle theorem. Measure of arc AXC is equal to 180 degree. Equation 2. Measure of a semicircle is 180 degree. Angle BAC is half into 180 degree. Equation 3. From equation 1 and 2, angle BAC is equal to 90 degree. Corollary 2. Angles subtended by the same arc are congruent. Given a circle with center O, angle ABC and angle ADC are inscribed in the same arc ABC and intercept the same arc AC. To prove, angle ABC is congruent to angle ADC. Proof. Angle ABC is equal to half measure of arc AC. Equation 1. Inscribed angle theorem. Angle ADC is equal to half measure of arc AC. Equation 2. Inscribed angle theorem. Therefore, angle ABC is congruent to angle ADC from equation 1 and 2. Cyclic quadrilateral. If all vertices of a quadrilateral lie on the same circle, then it is called a cyclic quadrilateral. Given points lying on the same circle are called concyclic points. Theorem of cyclic quadrilateral. Opposite angles of a cyclic quadrilateral are supplementary. Given ABCD is cyclic. To prove, angle B plus angle D is equal to 180 degree. Angle A plus angle C is equal to 180 degree. Proof. Arc ABC is intercepted by the inscribed angle, angle ADC. Therefore, angle ADC is equal to half measure of arc ABC. Equation 1. Similarly, angle ABC is an inscribed angle. It intercepts arc ADC. Therefore, measure of angle ABC is equal to half measure of arc ADC. Equation 2. Therefore, measure of angle ADC plus measure of angle ABC is equal to half measure of arc ABC plus measure of arc ADC from equation 1 and 2. Therefore, half measure of arc ABC plus measure of arc ADC is equal to half into 360 degree is equal to 180 degree. Similarly, we can prove angle A plus angle C is equal to 180 degree. Corollary of cyclic quadrilateral theorem. An exterior angle of cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. Given side DC of a cyclic quadrilateral ABCD is produced to a point E. To prove angle BCE is equal to angle BAD. Proof. Angle BCE plus angle BCD is equal to 180 degree. Equation 1. Angles in linear pair. Angle BAD plus angle BCD is equal to 180 degree. Equation 2. Opposite angles of cyclic quadrilateral. Therefore, angle BCE plus angle BCD is equal to angle BAD plus angle BCD from equation 1 and 2. Therefore, angle BCE is equal to angle BAD. Converse of cyclic quadrilateral theorem. Theorem: if a pair of opposite angles of a quadrilateral is supplementary, the quadrilateral is cyclic. Theorem: if 2 points on a given line subtend equal angles at 2 distinct points which lie on the same side of the line, then the 4 points are concyclic. Example: in the given figure, PQRS is cyclic. Side PQ is congruent to side RQ. Angle PSR is equal to 110 degree. Find 1. Measure of angle PQR. 2. Measure of arc PQR. 3. Measure of arc QR. 4. Measure of angle PRQ. Solution: PQRS is cyclic. Given 1. Angle PSR is equal to 110 degree. Given angle PSR plus angle PQR is equal to 180 degree. By cyclic quadrilateral theorem, 110 degree plus angle PQR is equal to 180 degree. Angle PQR is equal to 180 degree minus 110 degree. Therefore, angle PQR is equal to 70 degree. Equation 1. 2. Angle PSR is inscribed in arc PSR intercepting arc PQR. Angle PSR is equal to half measure of arc PQR. Inscribed angle theorem. 110 degree is equal to half measure of arc PQR. Substituting the given values, measure of arc PQR is equal to 110 degree into 2. Measure of arc PQR is equal to 220 degree. Equation 2. 3. Side PQ is congruent to side RQ. Given, that is, chord PQ is congruent to chord RQ. Arc PQ is congruent to chord QR. Corresponding arcs of congruent chords. Measure of arc PQ plus measure of arc QR is equal to measure of arc PQR. Arc addition property. 2 measure of arc QR is equal to 220 degree. Measure of arc QR is equal to 110 degree. Equation 3. 4. In triangle PQR, side PQ is congruent to side RQ. Angle QPR is congruent to angle QRP. Isosceles triangle theorem. Let angle QPR is equal to angle QRP is equal to x degree. Angle PQR plus angle QPR plus angle QRP is equal to 180 degree. Angle addition property. 70 degree plus x degree is equal to 180 degree. 2x degree is equal to 180 degree minus 70 degree. 2x degree is equal to 110 degree. X degree is equal to 55 degree. Therefore, angle PRQ is equal to 55 degree. Equation 4. Try some more problems for practice. Formula. If two chords of a circle intersect each other in the exterior of a circle, then the measure of the angle between them is half the difference of measures of arcs intercepted by the angle. BOD is equal to half measure of arc BD minus measure of arc AC. Example, in the given figure, measure of arc NS is equal to 125 degree. Measure of arc EF is equal to 37 degree. Find the measure of angle NMS. Solution. Angle NMS is equal to half measure of arc NS minus measure of arc EF is equal to half into 125 degree minus 37 degree is equal to half into 88 degree. Angle NMS is equal to 44 degree. Formula. Remember, when two chords intersect each other internally, then the measure of the angle between them is half the sum of measure of arcs intercepted by the angle and its opposite angle. Angle AOD is equal to angle BOC is equal to half measure of arc AD plus measure of arc BC. Example, in the given figure, chords AC and DE intersect at B. If angle ABE is equal to 108 degree, measure of arc AE is equal to 95 degree, find measure of arc DC. Solution. Angle ABE is equal to half measure of arc AE plus measure of arc DC. 108 degree is equal to half into 95 degree plus measure of arc DC. 108 degree into 2 is equal to 95 degree plus measure of arc DC. 216 degree is equal to 95 degree plus measure of arc DC. Measure of arc DC is equal to 216 degree minus 95 degree. Measure of arc DC is equal to 121 degree. Try some more problems for practice. Theorem of angle between tangent and secant. If an angle has its vertex on the circle, its one side touches the circle and the other intersects the circle in one more point, then the measure of the angle is half the measure of its intercepted arc. Let ABC be an angle where vertex B lies on a circle with center M. Its side BC touches the circle at B and side BA intersects the circle at A. Arc ADB is intercepted by ABC. Case 1. The center M lies on the arm BA of angle ABC, where angle ABC is equal to angle MBC is equal to 90 degree. Angle ABC is equal to half measure of arc ADB. Case 2. The center M lies in the exterior of angle ABC. Angle ABC is equal to half measure of arc ADB. Case 3. The center M lies in the interior of triangle ABC. Angle ABC is equal to half measure of arc ADB. Theorem of internal division of chords. Suppose two chords of a circle intersect each other in the interior of the circle, then the products of the lengths of the two segments of one chord is equal to the product of the lengths of the two segments of the other chord. Given, chords AB and CD of a circle with center P intersect at point E. To prove, AE into EB is equal to CE into ED. Construction, draw segment AC and segment DB. Proof. In triangle CAE and triangle BDE, angle AEC is congruent to angle DEB, vertically opposite angles. Angle CAE is congruent to angle BDE, angles inscribed in the same arc. Therefore, angle CAE is similar to angle BDE by angle-angle test of similarity. Therefore, AE upon DE is equal to CE upon BE. CSST. Therefore, AE into EB is equal to CE into ED. Example. In adjoining figure, chord MN and chord RS intersect at point D. If RD is equal to 15, DS is equal to 4, MD is equal to 8, find DN. Solution. Chord MN and RS intersect internally at point D. DM into DN is equal to DS into DR. Therefore, 8 into DN is equal to 4 into 15. Theorem of intersecting chords. Therefore, DN is equal to 4 into 15 upon 8. Therefore, DN is equal to 7.5 units. Theorem of external divisions of chords. If secants containing chords AB and CD of a circle intersect outside the circle in point E, then AE into EB is equal to CE into ED. Given chord AB and chord CD intersect at point E. Point E is in the exterior of the circle. To prove AE into BE is equal to CE into ED. Construction: draw segment AD and segment BC. Proof: in triangle ADE and triangle CBE, angle AED is congruent to angle CEB, common angle. Triangle DAE is congruent to triangle BCE, angle inscribed in same arc. Therefore, triangle ADE is similar to triangle CBE by angle-angle test of similarity. AE upon CE is equal to ED upon BE, CSST. Therefore, AE into BE is equal to CE into ED. Example: in the given figure, if PQ is equal to 6, QR is equal to 10, PS is equal to 8, find TS. Solution: in a circle, chord TS and RS intersect externally at point P. PS into PT is equal to PQ into PR. Equation 1. Theorem of chords intersecting outside the circle. PS is equal to 8 units and let TS be equal to X. PT is equal to PS plus TS, therefore PT is equal to 8 plus X. PR is equal to PQ plus QR. PR is equal to 6 plus 10. PR is equal to 16. PS into PT is equal to PQ into PR. From equation 1, 8 into 8 plus X is equal to 6 into 16. 8 plus X is equal to 6 into 16 upon 8. 8 plus X is equal to 12. X is equal to 4. Therefore, TS is equal to 4 units. Tangent secant segments theorem. Point E is in the exterior of a circle. A secant through E intersects the circle at point A and B, and a tangent through E touches the circle at point T. Then EA into EB is equal to ET square. Given a secant through E intersects the circle at points A and B, and a tangent through E touches the circle at point T. To prove EA into EB is equal to ET square. Construction: draw segment TA and segment TB. Proof: in triangle EAT and triangle ETB, angle AET is congruent to angle TEB. Common angle: angle ETA is congruent to EBT. Tangent secant segments theorem. Therefore, triangle EAT is similar to triangle ETB. AA test of similarity. Therefore, ET upon EB is equal to EA upon ET. Corresponding sides. Therefore, EA into EB is equal to ET square. Example: in the given figure, ray PQ touches the circle at point Q. PQ is equal to 12, PR is equal to 8. Find PS and RS. Solution: PQ is equal to 12, PR is equal to 8. Given. Here PS is a secant and PQ is a tangent. PQ square is equal to PR into PS. Tangent secant segments theorem. 122 is equal to 8 into PS. 144 is equal to 8 into PS. PS is equal to 144 upon 8. PS is equal to 18 units. PS is equal to PR plus SR. P-R-S. 18 is equal to 8 plus SR. Therefore, SR is equal to 10 units. Try some more problems for practice.